So you've probably played around with something like ChatGPT, right? And you've got to wonder, how in the world does it do that? How does it write a poem or debug code or tell a story? Well, today we're going to pull back the curtain on the core technology that makes it all tick, this really revolutionary idea called the transformer.
I mean, it really does feel like magic. Just like 3 blue 1 brown points out here, you can feed a system some nonsense, and it spits back a story that's not just coherent, but creative. It feels like it can infer things, like it just knows what a pie creature might be. So how does it pull off this magic trick?
That's the big question, isn't it? But here's the thing, it's not magic. It's a process, a really brilliant multi-step process. And by the end of this, you're going to get the core logic behind how a machine can build a story one single word at a time.
The first clue is actually hidden right there in the name of the most famous models out there, GPT. Let's just quickly break down what that actually means.
So GPT, it stands for Generative Pre-trained Transformer. Generative just means it creates stuff, in this case text. Pre-trained means it learned by reading a truly massive chunk of the internet. But the real secret sauce, the engine that drives this whole thing, is that last word, transformer. That's the piece of tech we're going to dive into.
Okay, before a transformer can do anything, it has to solve this one huge fundamental problem. See, computers don't understand words like happy or sad. They only understand numbers. So step one is all about translating our language into their language, math.
The process kicks off by chopping up any text you give it into these manageable little pieces called tokens. A token might be a whole word, like apple, or just part of a word, like the ing in running, or even just a comma.
Now each of these tokens gets assigned a unique, very long list of numbers. This list is called a vector. And here's the cool part, you can think of that vector as a set of coordinates, placing that token at a very specific point inside this giant, invisible map, a sort of meaning space.
And inside this meaning space, things get really wild. The model learns that the relationship between concepts can be represented by directions. So the direction from the point for man to the point for woman is the concept of gender, which means you can actually do math with words. If you take the coordinates for king, subtract man, and then add woman, you land almost exactly on the coordinates for queen. It's incredible.
So just how complex is this meaning space? Well, for a model like GPT-3, every single token is represented by a vector with, get this, 12,288 numbers. That's like a map with 12,288 dimensions of meaning, all working together to pinpoint exactly what a word means. Okay, so we've turned words into points on a map. But we all know a word's meaning can completely change based on the words around it. This is where the transformer's most powerful, game-changing feature comes in, understanding context. So this whole sequence of word vectors gets fed into the transformer, which is really just a stack of repeating blocks. The first part of the block is what's called attention, and this is the big breakthrough. It's where each word's vector gets to look at all the other word vectors in the sentence, all at the same time, and decide which ones are most important to its own meaning. It's like they're all talking to each other. After that, a feed-forward layer just does a little individual processing on each vector. And then this whole cycle repeats, over and over, layer after layer, getting more and more refined each time. The whole point of all these layers is for each vector to soak up the context from its neighbors. Think about the word model. In the phrase fashion model, the vector for model is going to get pulled in one direction by the word fashion. But in machine learning model, it gets pulled in a totally different direction. The transformer is what lets this happen.
But there's a limit. Its brain isn't infinite. An early model like GPT-3 could only handle 2,048 tokens at a time. That's its context window. This is exactly why, if you've ever had a really long conversation with an older chatbot, you might have noticed it starts to, well, lose the thread. The beginning of your conversation literally falls out of its short-term memory.
All right, so we've turned words into numbers and we've given them context. But how does any of that lead to creating new words? Well, it turns out this whole incredibly complicated process has one single-minded goal.
After all of that processing, all those layers of attention and refinement, the model focuses on just one thing, the very last vector in the sequence. The idea is that this final vector has absorbed all the information from the entire prompt and now holds the key to predicting what should come next.
And that prediction isn't just a single word. It's way smarter than that. It's a probability distribution over every single possible word it knows. So for a prompt like this, a well-trained model would give a really high probability to Snape,
maybe a smaller one to umbrage, and so on. It's basically giving you a ranked list of its best guesses.
Now, the model's raw output is just a big, messy list of scores. To turn that into the nice, clean percentage chart we just saw, it uses a final mathematical step called the softmax function. All you need to know is that it takes those raw scores and tidies them up into probabilities that all add up to 100%, making sure the best guesses get the highest percentages.
So the model can predict the probability of the next word. That's its one trick. So how do we get from that one simple move to it writing entire paragraphs or poems? Well, it all comes down to a beautifully simple loop. Here's how it works. First, the model predicts the probabilities for the next word. Second, it picks one, and sometimes it picks a less likely one, just to keep things creative. Third, and this is the key, it adds that new word to the end of the text it already has. And finally, it feeds this new, slightly longer text right back into itself and does the whole thing over again.
And that's it. That's the secret. This constant loop, predict, choose, add, repeat, is exactly what you're seeing in real time when you watch a chatbot typing out its response. It isn't thinking 10 steps ahead. It's just figuring out the very next best word over and over and over again.
Now, to make this process work with that uncanny accuracy we see, the model needs an absolutely astronomical number of tunable knobs, or what we call parameters. For GPT-3, we're talking about 175 billion of them. These are all the little internal settings that get adjusted during its training, and they basically represent everything the model has learned.
So, we've walked through the process. Words become vectors, vectors soak up context, and then the whole system just predicts the next most likely word in a loop. It can mimic human language in a way that is just stunning. But it leaves us with this one giant question. Is this system actually understanding anything? Or is it simply the most sophisticated, most complex pattern matcher the world has ever built? And you know what? The answer to that is still very much up for debate.